All right, let's dive right in. Today, we're going to break down a really core challenge in web development. How do you secure an app that needs to scale? I mean, really scale, to millions of users. We're going to look at how modern apps figure out who you are and what you're allowed to do, all without the server having to keep some giant, messy list of every single person who's logged in. So, let's start with the big puzzle right here. Just imagine you're building the next huge thing, a global app, millions of people signing up. How in the world do you manage their access securely without this single giant master list that you're constantly updating? It sounds almost impossible, right? But the solution is, well, it's actually incredibly elegant. And the answer? It's all about completely flipping the script. Instead of the server trying to remember you carry your own proof of who you are. We're talking about a digital token that works just like a passport. It's totally self-contained, it's digitally signed, and any server can verify it on the spot without having to call home to some central authority. But before we get into all the cool details of this new passport, it's super important to understand why we even needed it. So let's take a quick look at the old way of doing things and all the headaches it caused. Okay, so the old approach is what we call a stateful session. Think of a bouncer at a club with a physical clipboard. He has to find your name on the list, check you in, and remember that you're inside. The new, stateless way, totally different. The server doesn't have a list. It just glances at your token, your passport, and if it looks legit, you're in. It doesn't need to remember you because the passport itself has all the proof it needs. And that bouncer's list? Oh man, it creates huge technical problems. Let's say you add more servers to handle more people. How do they all share the exact same list in real time? It's a scaling nightmare. Then you run into these annoying cross-domain issues. That's when your website and your API are on different domains and they just don't want to talk to each other. The fixes for this stuff get really complex and expensive really fast. And this, right here, is the bottom line. When your server is responsible for remembering every single active user, your ability to grow is just fundamentally capped. It's just not a system that's built for the modern web. So this is where our hero finally enters the story. The Stateless JSON Web Token, or JWT for short. This is that digital passport we've been talking about, and it's what solves all those nasty scaling problems. So a JWT is basically just a standard, agreed-upon way to create these self-contained tokens. The two keywords to remember here are claims and digitally signed. Claims are just facts about you, like here's your username, here are your permissions, and digitally signed, well, that's the magic part. It means the token is sealed with a secret key, so the server knows instantly that nobody has messed with it. So a better way to think about it is less like a generic passport and more like a cryptographically sealed VIP pass. It doesn't just say who you are. It lists exactly what you're allowed to do, your roles, and importantly, when the pass expires. And this is the incredible power of being stateless. The server doesn't have to look you up in a database every time you make a request. All the proof it needs is sealed right inside the token you're carrying. All right, theory is great, but let's get practical. How does a secure request actually travel from your browser to the server and back again? Let's break down the whole journey and look at the three key players in this process. We've got three main characters here. First, there's the passport office. This is the service that actually creates and signs your token when you log in. Then we have the border guard. That's a filter that checks every single request coming in to make sure it has a valid token. And finally, you've got the room bouncer, who checks the specific permissions inside your token before letting you into a protected area. The whole journey starts on your end, in the browser. After you log in and get your shiny new token, a little piece of code called an interceptor automatically staples that token onto every single request you make. It adds a special header called authorization that basically says, hey, here's my proof, followed by that long token string. Next up, that request hits the server, and that's where our border guard, the filter, steps in. It's the first line of defense. It grabs that token from the header, makes sure the signature is legit, and then pulls out your identity, like your email address, from inside it. Okay, and finally, once your identity is confirmed, the request gets to the specific thing you were trying to do. This is where the room bouncer takes over. A little annotation, like this @pre-authorized one, checks the roles baked into your token. If the token says you're an admin, you get in. If not, you get denied. Simple as that. Now, this all sounds pretty fantastic, right? I mean, it's scalable, it's efficient, it's secure, but there is one major trade-off with this whole stateless approach, a really crucial catch that we have to talk about. So here it is, the million-dollar question. If this token is a perfectly valid, self-contained passport, What happens if it gets stolen? Or what if you need to log a user out, like right now? How do you cancel a passport that's already been issued and is out in the wild? And the blunt answer is, you can't. That's the heart of what we call the revocation problem. Once that JWT is created, it is valid until its built-in expiration date, period. The server has no way to reach out and say, hey, that token's no good anymore, because the whole point is that the server isn't keeping a list. You just can't unsign it. But don't worry, this isn't a deal breaker. Some really smart engineers figured out a super elegant compromise. It's a two-token strategy that gives us the best of both worlds. All the performance of stateless tokens, but with the control to revoke access whenever we need to. And this solution is just brilliant. Instead of one token, we use two. The first is a short-lived access token. This is the passport you use for every request, but it expires really quickly, say in 15 minutes. The second is a long-lived refresh token, which we do keep track of in a database. Its only job is to get you a new access token. And because that refresh token is in our database, we can delete it whenever we want. And just like that, we have complete control. If someone leaves the company, we don't have to worry about the access token they have. We just go into our database and delete their refresh token. The very next time their short-lived access token expires, which will be in 15 minutes or less, they won't be able to get a new one. Their access is cut off. Problem solved. So let's bring it all home. We've seen how stateless JWTs are perfect for modern, scalable apps. We followed the entire flow of a secure request from the client through the server's border guard filter, all the way to the room bouncer permission check. We also stared the big revocation problem in the face and saw how to solve it cleanly with that two-token strategy, short-lived access tokens for speed and a revocable refresh token for control. And that's really the whole story. We've seen how this powerful digital passport pattern can give us security that actually scales. So the final question I'll leave you with is this. Now that you get the pattern, where else in your own projects could you apply this idea of a secure, stateless, self-verifying token? Thanks for tuning in.